Hi, I'm Hank Weichel of FabLab Hub, and welcome to our series on the fundamentals of 3D printing. The choice of orientation of your model can greatly affect the outcome of your final print. Not only does orientation affect the amount of support material that's needed, which in turn affects total print time, but the orientation can also affect the visual quality and the strength of the final print. Parts that have overhangs require support material to print properly. More on this in a future video. By strategically orienting your prints, you can reduce the need for support material. This has a number of benefits. First, laying down support material takes time, so reducing the amount of support material reduces the total print time. Additionally, when support is added, it must eventually be removed during the post-processing phase of the project. This takes additional time and provides yet another incentive for keeping support to a minimum. Finally, support material can leave scars on the surface of prints. This not only affects the visual quality of the part, but can also affect the tolerances for functional parts. An important drawback of FDM is that parts manufactured using the process exhibit anisotropic properties, meaning that material properties such as strength are different along different axes. For this reason, it is important to consider this when orienting parts, especially for functional prints, where material properties are of utmost importance. The strength of a 3D printed part is limited by the strength of the bonds between adjacent layers. It is at the interfaces between layers that a part is most likely to fail or delaminate. To maximize the strength of bonds between layers, you should shoot to maximize the surface area of each layer. A larger area of contact between adjacent layers translates to a stronger bond. Long, tower-like parts are best laid down on the build plate rather than printed on end. In addition to affecting scarring on the surface of a print, the orientation of a part can also affect the degree of stair-stepping that occurs. Since FDM approximates models using a series of flat layers, curved surfaces cannot be reproduced exactly. Instead, they are created by stacking rectangular pieces, giving the appearance of stairs. While the layer height has a large effect on the degree of stair-stepping, orientation also plays a role. Stair-stepping can be reduced by orienting curves with the highest degree of curvature parallel to the surface of the build plate. Since the minimum X and Y distance is much less than the minimum layer height, curves oriented in the XY plane can be produced with higher fidelity than curves printed at an angle. When orienting parts with fine details, avoid orientations that would result in supports being placed on top of those details. This could result in damage to those details when supports are removed. Instead, orient parts so that details face upward, away from the build plate. Large flat surfaces should be oriented towards the build plate, as they provide ample surface area for support placement and can more easily be cleaned up during post-processing. Remember that there is no single correct way to orient a print. Often it will be impossible to optimize the orientation of your print for all of the considerations discussed. Instead, make decisions about orientation intelligently, taking into consideration the specific requirements of your project. This will help ensure the best possible quality for your print. In this video, we've discussed many of the byproducts of orientation that you should keep in mind when preparing your model for printing, and we hope that you will now feel more comfortable making decisions about the orientation of your models. As always, thanks for watching.